All right, good morning. So welcome to, she's about to do that. Welcome to Math 115 ASO3. If you had the early syllabus that I changed, there'll be cats in here all the time. So there's nothing I can do. They ignore me all day. And then as soon as I try and do a Zoom meeting, they're all over the place. So I'm your instructor, Adrian Biglance. Let me move this over so I'm not staring to the side. Today, what I'll do is I'll break down what the heck is going on with the course this semester, and then we'll organize, and then I'll start some math. If you got questions, you can ask at the beginning or during today. Basically, I'll share my screen and I'll share the Blackboard website. I'll share the course outline and that kind of stuff, and decide exactly what we're doing this semester. I don't think anybody knows, but here we go. So let me stop sharing this, and then I'll share my screen first, and then we'll get to do some math. We'll start with inverses. Well, I'll probably just start with a review of 114 so that we're all on the same page, and the things that I'm going to use eventually in 115 that are similar to 114. The first things first, the problem with 115, why 115 is markedly harder. It's only with two ways to motivate: fear and reward. So I'll scare you right away, but 115 is much harder than 114. One of the major reasons is we're going to do integration or anti-differentiation as well as differentiation, but we're going to focus on a lot of integration techniques, which are much harder in general than differentiation techniques. And then we're going to, Kitty, just a second.
Kitties, yeah.
Sorry. Welcome to classes at home. I got to chase cats away. Thanks. Yeah. I'm half allergic to all the cats that are running around. Every time they run around, there's cats running around. They mess with stuff. So you'll get used to that. You don't have to say bless me every time, but thanks. So they want this to be a hybrid class is basically, so the reason this is going to be much more difficult, there's sort of two strains of why. First, we're going to do anti-differentiation, which is much more difficult in general than differentiation. And then on top of it, we're going to start adding in new functions, transcendental functions, which we expect we're going to add in new techniques. So then we have to relearn limits at points with transcendental functions and limits at infinity, horizontal and slant asymptotes, etc., for transcendental functions. And so differentiation of all these transcendental functions. So we're going to get this new lexicon of a bunch of horrible functions. And then we have to know how to do the same techniques from 114 on these new weird functions. And then on top of it, we're going to try and integrate or anti-differentiate a bunch of them. And we need techniques because we don't have the chain rule, product rule, quotient rule, etc. for these functions. So this is sort of why it will feel a lot stranger, but I will try to mimic what's going to happen with 114. Before we do that, let me stop sharing, and I will share my desktop, and then we'll go through the course outline first on how we're going to run this class. Share, I want to share desktop 1. So I'm basically just in, if we go to Blackboard, and then we go to 115, as I'm hoping you already have, but possibly not. Everything is going to be in course content. Go to course content. And then this is where everything will appear throughout. I haven't put up assignment 1 yet. This will happen right away. It's not due yet, I don't think, till a couple of weeks from now, but I'll put them all in here, and they'll be through CrowdMark, and you'll submit through CrowdMark. Midterms will be in here, etc., and the final exam. So I have a folder for each one. Most of the assessments will be through CrowdMark. Midterms, it'll just be PDFs preparing you for the types of questions for the midterms, because they want us to do a hybrid, so they want us to do in class. So the exams will be in class. on Thursdays of the week that they're indicated. And then the final exam, same thing. I would imagine we're going to be in 5-152. So I can see. So basically, I'm Adrian Biglands. What we're going to do is there's the first one. For now, because we're doing this COVID, the first month we can't go in roughly until they change this restriction. I also have a daughter who has to be at elementary school at 8 a.m.-ish. So they stuck me with an 8 to 9:30 class, but then they called it online asynchronous. Online asynchronous means that we shouldn't be meeting specifically. Then I got an email this week saying, no, they're hybrid now. So that means that we have to do some in lecture stuff, not only some in lecture stuff, but some has to be online and then some has to be in class. I didn't want to explain that this is a contradiction in terms because online asynchronous means we don't meet regularly, and then hybrid means that we do meet regularly, and not only do we meet regularly, but we have to meet in class and out of class. So I don't know, but this is what we're going to do for now. Usually I'll start the meetings as close to 8 a.m. as I can, but officially we'll make it Tuesdays, Thursdays, 8:30 to 9:30, mostly because I have to drop off my daughter in the winter snow and then get back home or to a computer as fast as I can and start the Zoom meetings. So we'll do Zoom meetings roughly from 8:30 to 9:30 every morning. Today was different because it says 8 a.m. on the PeopleSoft, so I knew everyone would show up at 8 a.m. But you get an extra half an hour to sleep in the mornings, you're welcome. We'll start usually at about 8:30 to 9:30. We'll do a solid hour, and then you can run away on Tuesdays and Thursdays. Once they do lift this restriction, I will do, so I can write this in here, course outline. And of course, this semester. So one, we will meet Tuesdays and Thursdays from 8:30 to 9:30 a.m. I will post these. I'm downloading them onto this computer right now, I think, not onto the cloud. Either way, I'll post these videos in hopefully a prompt manner after we do each lecture. And if this doesn't work out, well, the Zoom meeting specifically, the Zoom meeting should work out, but if I will also try to have some videos on my YouTube channel related to this. Just wait, I gotta check the chat. Well, 9:20 is whatever it is, the 9:20. I'm aware you have classes right after. I have 3 classes today, 2 at McEwen and 1 at Concordia. So yeah, once this starts, don't worry, it'll be 9:20 then. Whatever it's posted, it's usually 8 a.m. to 9:20 a.m. So specifically that these hours have 50 minutes. These hours have 50 minutes. So in real time, yes, I'll be at McEwen, and then I have to leave and go to Concordia, and then I have to come back to McEwen or go to my office at Concordia and do a Zoom meeting in so for my lab that I have later today as well. So it's going to be a shit show. So yes, I'm aware we have to keep to the hours that are officially our hours, and we will definitely do that. And I won't be canceling any classes. I like math. The lectures are the parts that we want to do, but I'll get used to it. Just Murphy's Law, they jammed all my classes into Tuesdays, Thursdays this semester. So my other days will be where I can run around and post videos and make sure everything else happens. So 2, I will post 3 lecture videos. I have to ask again, I think if I post these on Blackboard, it might fill up the memory too fast. So I will probably end up putting them on YouTube, on my YouTube channel in the playlists. I'll make another separate playlist for like our ASO3 live lectures. And then I'll just try to prepare some relevant videos for the topics that we do in the class anyways on the YouTube channel. I'll get to that in a second. So once the restriction is lifted, I'm in my daughter's office right now, and sometimes I might be in the kitchen too, or I might be in my office at McEwen. I don't know. We'll see how this goes. But my daughter got the kids got the week off this semester, so she's still in bed sleeping, and I have to be the one awake right now. We will meet in person on Tuesdays from 8 to 9:20 a.m. in 5-152. 5-152 are those the amphitheater ones in building. Oh no, these are just the nice ones. I don't know what 5-152. I thought 6-512 are those amphitheaters, but apparently 5 is just going to be some reasonably large room where we can spread out apparently. Five does, okay, yeah. I'm assuming it's going to be one of those ones because we want to have as much space as we can. But I haven't been to McEwen on campus for a while, so I'll find it with you in February or whenever they start letting us go in person. So 4 is, let's do the course evaluation, which is the important part. So also, yes, have a read through. And yes, I'm going to get to that right now when we do the course evaluation part, but the exams are going to be in person. I think that's McEwen's clever way of saying we need to start doing exams in person so we can monitor everything. Otherwise, it's just the Wild West out there. So that's what I'm going to get to right now. Is all these things. There's no official textbook. What I will also do is, if I haven't already, I will post. I've been trying to edit them as much as I can because there's little typos and stuff everywhere. Some of the numbers are wrong, but I have my own lecture notes for 115, including a review of 114. So I will post these post haste, so you can use my lecture notes, which are in a slightly different order than the Stewart calculus, but the one that they usually follow is the James Stewart calculus. I have the 8th edition or the 9th edition. If you look on the internet, you can find a PDF copy, but fairly easy, so I wouldn't rush out and buy it, but find an 8th or 9th version, and they should be good enough. This is the sections that they follow at the end. I'll show you in a second. And then the coordinator, Sunil Baran, has put up a bunch of links to a bunch of other calculus resources. But my lecture notes and the Stewart calculus version 8 or 9 should do well enough. Don't rush out and buy a textbook. You don't need one. And then what else are we going to do? So here it is, the grade evaluation. So 1, we have term tests. There's going to be times 2, and so that will be 21% each. I didn't make the percentages. Sunil always makes the percentages. Why do you have to make it 21%, etc.? I don't know. But here we go. The assignments, which I'll start posting right away through Crowdmark, will be 12%. I think there's about 5 of them. I'm not sure. So we'll see how he's doing that. I don't know. If there's 5, that means they're worth, I don't know, some weird amount each. Maybe there's 6. I don't get to coordinate everything, so I don't have control exactly of the assignment questions, etc. This gets passed down. The lab quizzes are going to be 15% each. There's 3 lab quizzes. They're indicated below just in a second. I'll get there. And then the final exam is 31%. Yeah, I don't know how many, I can't remember how many assignments there are. Math is hard. Yes, I just don't know how many there are exactly. And then, oh, for the lab quizzes, yes. The lab quizzes will be 5% each. The math works out. 3 times 5 is 15. I just mean for the assignments, I don't know how many there is or how much they're going to be each, was what I was saying. If there's 6, then they're 2% each. But if you made it 5, then it's some weird percentage. But yeah. And then, so what else do I need in there? So yeah, let's make that. Exams are in person on Thursday. The first one is March or February 3rd, 2022, in class. And the second one is, I'll just write it in so we have it in our first lecture notes, March 10th. In 5-152. And then the final exam, I'll let you know when we get closer. It'll be in the PeopleSoft schedule. So yes, I don't know. Now I have to remember how to use the printing service and remember what my pass is at McEwen, I guess, but I will print off paper copies for everybody and that will make it easier. The good news is you're gonna have to watch me monitor you and walk around, and then there's no cheating anymore, online cheating anymore. Not that anybody's been cheating, right? I would too, I don't know. So you're gonna have to have me walk around, but at least there's no stress of the electronic process or how do I submit or it's not opening or any of that kind of stuff. So hopefully that should relieve some of the stress and not the other kind of stress. So at least when we're in class and we're doing the exams, we know that when I hand you the paper copy, it works, and then you get your questions and everything like that, and then you can ask questions in real time. And again, they'll be gauged to be about, I would imagine, 50 minutes long is how often. I won't do a full hour and a half midterms. I'll do probably 50-minute exams in the same hour or block, 8:30 to 9:20-ish, and then you guys can go after that. I also don't know how that works. This semester is going to be crazy for you guys. What if you have an in-class exam from 8 to 9:20 at McEwen, and then you have an online one after? I guess you use your phone or something if you have a class right after. That's weird. I don't know how this is going, but here we go. So all tests and materials should be submitted through this. This is just a disclaimer in case anything is online. Yeah, I got it wrong already. I don't know if you had the first course outline, but I followed PeopleSoft and it said online asynchronous, which means no real meetings. So I'll just prepare a bunch of videos and then you can watch, and then I'll make office hours and we can discuss once a week if you want, types of things, and I can do some problems. But then the chair Adi emails immediately and is like, no, it has to be hybrid and you have to have in-class ones. I'm like, how do you have an asynchronous lecture? That seems like a contradiction. So yeah. Everybody's frazzled, they just don't want to admit it. I'm frazzled, I don't care anymore. They keep changing everything minute to minute, so I don't know what's going on. And I'm at 3 different universities that have the time, and McEwen's using Blackboard, and Concordia's using Moodle, and U of A is using eClass, and then inside these, it's like U of A is using CrowdMark, and you guys, McEwen's using CrowdMark, and or Blackboard Collaborate, and then Concordia is using something else. It's less like for the Zoom meetings, McEwen's using Zoom meetings and Concordia is using Google Meets. It's like, I don't know what's going on. Too many programs. I'm sick of it. So I feel your pain. If you're confused, I'm confused too. They keep changing everything and I have to know so many programs. I don't know what's going on. The good news is I do know how to do math. So when we get to the math, then we'll know what's going on. This will be the good news. For lab quizzes, we have one in week 4. That's January, so in a few weeks. Whatever day of the week your lab's on. And then quiz 2 will be in week 7. This is Valentine's Day to the 18th. And then the third one is in week 13. Right at the end, it looks like. Probably after we have all the integration techniques and applications. This is March 28th to April 1st. Okay, get out of there. This is the one, this is the bad one. The murder cat. She's trying to get, she's in all the cords at the bottom of the table right now. It's like, what are you doing, kitty? Yeah, get in there. Okay. Her tail will just sit here now. And this is why I sneeze. Kitty, go here. Now it's like, pay attention to me, not the cat in the background. It's like, I said, no, it's hard. Don't think about elephants. All right. I think, oh, I didn't move that down correctly. I think everything else should be fairly straightforward, except for, so in the last page is the course outline, is where you find the tentative schedule and the lab quiz schedule and the assignment schedule. So this is why I haven't posted assignment 1. I'll figure that out, and I have to email the coordinator soon and be like, I don't know how to use Google Drive. Stop sharing stuff in Google Drive. I just want to have the PDF copies of these, and then I'll put the assignments in CrowdMark for you in our section. But the last page of the course outline has the weekly schedule. Or tentatively in the Stewart Calculus book, which sections we're going to use and what the topics are. I also have my own lecture notes, and so it'll be a slightly different order. I can email you Monday of each week to be like, these are, Kitty, get out of there. She's just in the cords at the bottom. She's gonna like press the button on the power cord or something, and then everything will just go blank. So if and when that happens, just give me a few minutes and I'll start everything up again. But she's trying to mess with the cord at the bottom by my feet. So I'll send an email every Monday, hopefully, and then this will tell us what we're going to do this week, what you should read this week from my lecture notes and or from the Stewart Calculus book or one of the online ones, give you the topics. And then if I do post some videos, I'll let you know where they are. And then in here, it should be, I don't think I put anything in except I was going to start putting in some 115 labs. So if you go here, this will go to YouTube. And then if you go in here, it has a playlist. Right now, I just put some I happen to coincidentally have a video on one-to-one functions. So you can watch in there. I don't know how regular this will be because I have several different classes at a couple different universities this semester. So I might, once the semester starts, I might be running around doing a bunch of tasks. But on top of it, yeah, I'll try to make some YouTube videos and add some of the topics in there so you can watch them anytime you want, on top of the live lectures that we're recording. I will probably make one more playlist that says live lectures for ASO3. So that'll be these videos. And then the other ones where it's me at the whiteboard will be this 115 playlist. I'll start that going this weekend once I don't have lectures. Anything else about the course outline? I don't think. No. That's pretty well the course outline. Did I forget anything? I don't think I did. So the biggest up in the air is when do we meet? Well, we will meet Tuesdays, Thursdays, 8:30 to 9:20. Once we start in class, I'll try to be there right at 8 a.m. for you guys. But again, between the traffic and the snow and getting my daughter to elementary school first and then getting to McEwen downtown, it's going to be quite the task. Why do I have the 8 a.m. class? Because the full-times get to pick first and then I get the leftovers, and apparently no one else wanted to teach at 8 a.m. So here we are. I don't know how you got stuck with it, but here we go. In case you were wondering, I like to sleep until 12 and then have my classes in the afternoon, but such is life. Got to be here at 8 a.m. All right. So if there's no questions about the course outline, that seems reasonable. Once it goes back to normal, I guess, with the COVID scenario and we're allowed in class, Tuesdays will be in McEwen, Thursdays will be online in the Zoom meetings, and then, yeah, it looks like it. I didn't make these. If you want, I'll double check when he's adding these in, but yes, because it's online and it's through Crowdmark, it doesn't have to be Friday. Normally we used to make the assignments due at like 5 p.m. because I have to go to a box and pick them up. And then I don't want to be here past 5 o'clock on a Friday or whatever when they're due. But now that they're Crowdmark and they're online, I will set the assignments due for whenever the coordinator says to have them set, so that every section has them submitted. But if it's Saturday at 1 p.m., then it doesn't matter to me. We can usually, I don't know if 1 p.m. is correct, but I will double check this, and then it will say right in the assessment and everything else when they're due. But yes, we can set them due any day of the week. I have a couple of mine due on Sunday for Concordia as well, because why not give the weekend the extra couple days to do these? So yeah, the time of submission doesn't really matter to me anymore. I don't have to make it Friday at 3 p.m. anymore. We can make it Saturday late in the evening or whatever else, because it'll be all through Crowdmark. But that will be posted sometime this weekend, and then you'll know for sure when it's, what the questions are and when it's due. And then hopefully he gives me all the PDFs at once if they're ready. We have to change the questions slightly because everything goes online as well. So I would imagine he's preparing these, but then once we get them, I'll just try to have them all posted in prompt order. But the first assignment will appear this weekend sometime. What else did I forget? Anything else? I don't think so. Yeah, so there I see January 29th by 11 p.m. If you're asking me if I know that January 29th is a Saturday, I did not know that. Nor did I make that. I'm just following what the coordinator wants. I didn't make the tentative list. This is the tentative list made by the coordinator, Sunil Baran. I just follow it because we want to submit all of them at the same time so we can release them all, the solutions, etc., at the same time. But yeah, why not? I'd have made it Sunday at midnight, but it's fine by me. Anything else on the course outline? Your lab should tell you, your lab section, just go with the day and the time that this should be. That's the only thing I didn't do. So these ones are hybrids and the other ones are online asynchronous. So depending on your instructor or what this means. Again, they told me originally this class was supposed to be online asynchronous. And then they're like, no, hybrid. I'm like, I don't know what we're doing. But apparently hybrid is online asynchronous. PeopleSoft still says online asynchronous, and then they want us to meet in class and in Zoom meetings. I'm like, what does asynchronous mean? But here we go. So what are we supposed to do today? We're supposed to do, if you go in here, it'll say today classes begin, and then in this week, we're supposed to do inverse functions and their derivatives. Basically what I'll do today is I'll give definition of what an inverse function is, and then everyone will nod, but then there's going to be some clever tricks that we're going to have to use specifically when we get transcendental functions, when we can't solve for the inverse. And we'll get some clever tricks on how to deal with the inverses of transcendental functions. And then we'll work at finding the derivative and antiderivative of them all. So let me stop share this. And then I'll share my iPad again. So as I was going through, I wrote all this down for you so that you have it on the first page. This is just the stuff that we went over. I will post the PDFs in Blackboard, and then I will post the videos in Blackboard. Unless there's too much memory, I'll just make a playlist in that link for, and I'll add another link for the YouTube channel, and then they will just appear in there. YouTube, you can make as big a video as you want, and you can add as many as you want. So let me just get the chat out again so that we can see this in case someone chats at me. All right, any other? No more questions. Let's do some math and then we can get out of here. So we got an hour at least to do some math. So 1, 2, oh, I was just gonna check one more thing. Where is it? Oh, I did. So there is my lecture notes up there. I'm suspecting I will update the lecture notes quite often, and then I'll put the date in brackets that I've updated it, because I've been finding a bunch of typos and little number errors and stuff in some certain places. But if we go in there, it's section 1.2 in my lecture notes, one-to-one functions and their inverses. And then I just go through the different types of transcendental functions and then find their inverses of all the transcendental functions. And then we want to find the derivatives and integrals of transcendental functions. And then we'll do L'Hopital's rule and all these types of things, revisiting limits on how to do these horrible transcendental functions. So one-to-one functions and their inverses. So what we're trying to do is we're trying to find a way of, a function is a rule that moves points around into some, and then you get the graph of a function. What we're trying to do is invert that graph or reflect it about a line y equals x and find the reverse process of winding backwards that process of f. So if f is a plane ride to Europe, then we're going to find a different function, which is going to be the plane ride back from Europe. And then once we do this, it will leave us at the same point originally. So what is the definition of an inverse function? First of all, we need a certain class of function which we can invert. You have to be one-to-one. And what does that mean? You have to have that every point goes to a unique place, because if you had a choice, then if I'm trying to reverse the process, I don't know where that point's supposed to go. And so this is confusing, and we don't know where we're supposed to go back to. So the first thing that we have to have an inverse of a function is to have a way of saying, okay, we need a certain type of function, which is one-to-one. One-to-one means that a unique point goes to a unique image, essentially. And then they confuse this because they never put the actual way that we check one-to-one functions as the definition. So the first thing we have is definition. What is a one-to-one function? So f from A to B is called one-to-one or injective in some books. If in plain English, it never takes on the same value twice. i.e. for x1 and x2 inside the domain A, we have that if x1 does not equal x2, this implies that f of x1 does not equal f of x2. This is not, unfortunately, how we show one-to-one though. So, or equivalently, I put, this is the contrapositive. Statement. If we negate the conclusion here, not is f of x1 equals f of x2. This is my favorite. Homer Simpson says, I'm not licking frogs, Lisa. So what is not? That means it is. So if we have the negation of a negation, this is f of x1 equals f of x2 implies x1 equals x2. We have these two statements, but this one is how we show this is the second statement is actually how we will show a function is in fact one-to-one. So we can start off with this fairly simple. And what that means intuitively is you don't want to think of too fancy a function, but if we look at x squared, then we can see that f of -1 equals 1 equals f of 1, but -1 does not equal 1. So not one-to-one. So x squared is not a one-to-one function. X cubed is. That's the picture. We can't prove that algebraically. We show this as follows. So 1, if I have f of x equals x squared, this is, yes, we'll get to this when we have to restrict for the trigonometric functions. Sine is not, sine looks like this, right? Even the axis, but it shows you there's, it's definitely not one-to-one, is it? So if sine is not one-to-one, how can you have, how can your calculator have a little sine minus 1x? How can there be an inverse? What we're going to do is, instead of this function, we will restrict to an interval where it is one-to-one. And then it does pass the horizontal line test. And then we can invert sine just in that interval, -pi/2 to pi/2. We'll get there in just a second. But how do I know on its domain of definition that it's not one-to-one? Because you will get choice. If we assume that f of x1 equals f of x2 for some x1 and x2, then we have that, what is the definition of f? In this case, he's x squared, so that tells us x1 squared should equal x2 squared. But then what I'm going to do is I'm going to use square root, which gives us a plus or minus. And so it gives us choice. As soon as there's choice, that means that x could be plus or minus just because they're equal at any point. If I have this point, there's x2, say, and then just because they're equal, it told us they could be plus or minus each other. So what that's going to show us is just because the f value was the same doesn't mean that the x value, x1 value, or that has to equal the x2 value. And this says he fails the horizontal line test, and the horizontal line cuts it more than one place. And so this means that he's not one-to-one. But what does that look like algebraically? This would say that x1 equals plus or minus x2, because the square root, remember the square root of x squared is equal to the absolute value of x, which is equal to plus or minus x. Because -2 times -2 is 4, and 2 times 2 is 4. So when we're taking the square root of 4 or 2 squared, we get plus or minus 2. So if we're doing this, this is what we're saying. This says x squared equals 2 squared. And then that will say, when I take the square root, that will say x is the square root plus or minus of 2 squared, which is plus or minus 2, if we're trying to solve this. So what does that say? Not one-to-one. For the second one, if I have f of x is x cubed, how do I show it's one-to-one? Then we assume always that we have x1 and x2 in the domain, in this case R, with f of x1 equal f of x2. What does that mean? That's by the definition of f this time. This says x1 cubed equals x2 cubed. If I take a third root this time, though, this will be fine because third roots are not even, they're odd. And so this will say that the third root of x1 cubed is equal to the third root of x2 cubed. And these will just cancel off. We don't get a plus or minus. And so this says that x1 is equal to x2. So if f of x1 equals f of x2, this implies that x1 is equal to x2. Therefore, so f of x is one-to-one. So yes, this is the horizontal line test. The horizontal line test says exactly what we were just discussing. If you want to make a function one-to-one, graphically, it has to pass the horizontal line tests. Algebraically, we can restrict the domain to make that happen if it wasn't originally. So this says f is one-to-one if and only if no. So f of x is one-to-one on an interval if and only if no horizontal line intersects the graph twice. Intersects the graph of f more than once. I was supposed to say once. So, example, let f of x equal x squared, and then consider 1 on r versus 2 on the interval 0 to infinity. That's a round bracket. It's my orange juice breakfast. It's the first week of class. I'm gonna have to get used to getting up at 7 in the morning to be ready for 8 in the morning. So pictorially, we will see what's happening here. The point being is the algebraic expression is not the only thing that defines the function. The domain of definition that we give it also tells us that they're not the same function. So if I do x squared from r to 0 infinity, this is going to be the classic x squared that you're used to seeing. Not one-to-one. But as is commented by Clarissa, if I restrict now to the same algebraic function, it's still x squared, but now I'm going from 0 infinity into 0 infinity, my range. Then I'm just going to get 0 and the right branch. Still x squared, but now definitely one-to-one because it doesn't intersect anywhere. So is one-to-one. So this bothers people at first, but it's still the algebraic expression x squared. But the definition of one-to-one depends on the interval. So it's not just the function you take, the algebraic expression, it also has to be the domain that you're using. The combination of the algebraic function sine and the fact that we restrict to negative pi over 2 to pi over 2 will give these weird, clever tricks that they're going to try and get you when we use trigonometric functions and then inverse functions for exponential functions or the logarithms and these types of things. Yes, and that's why they call it injective. It's like one arrow hitting each point. That's exactly the way we can rephrase this, that it never takes on the same value twice means that a unique point goes to you in a unique image. That's exactly the way that we're rephrasing this. Never takes on the same value twice. Rephrasing that semantically is that yes, a unique x value will go to a unique y value. And that's not what happens with x squared, because we can have 1 and minus 1, and they're unique, but they go to the same value 1 in the image. So that's not one-to-one. If you have that, and you can restrict that anywhere you want, and we'll get into that when we do the transcendental functions and the exponential functions and all of these inverses on Tuesday next week from home, luckily still. Maybe then the COVID will just allow us to be at home all the time, and then we won't have to trudge through the snow. But we'll see what happens. So this is why, again, when we get to, and I start discussing all of the transcendental functions, the trigonometric functions, the exponential functions, and then the hyperbolic functions, when we do those, they all have inverses, but we have to restrict their domain depending on when they're one-to-one or not. This is, first of all, we can go through quickly for the trigonometric ones, if you found them, how we find their inverses. We have to restrict the domain first. So for sine of x, in this course, I'll talk about all 6, but in general, when I do this, you're welcome. When I talk about trigonometric functions or hyperbolic functions, I'm going to stick to sine hyperbolic, cos hyperbolic, and tan hyperbolic, and sine x, cos x, tan x, and then we'll get a to the x and the inverses logarithms, because then we're going to get arc sine and arc cos and arc tan and arc sine hyperbolic and arc sine cos, or arc cos hyperbolic and arc tan hyperbolic. And so we're going to have these weird trigonometric functions and their inverses, arc sine or sine inverse, and then these hyperbolic functions, sine hyperbolic, and then it's inverse, sine hyperbolic inverse, etc. So when do we make sure that these are one-to-one first, and then we'll worry about finding their inverses? So making the trigonometric functions, and I'll focus on sine and cos and tan. So not only can we do it, but we should do it immediately. So for the first one, when we're going to invert, what does sine look like? Sine goes from, as a function, where does it go originally? It goes from all of r into -1, 1. So this is algebraically, whether you've viewed it that way or not, that's the sine function. Where does he go? He goes from, what are the mantras of domains? There should be 2 mantras. We'll get a third one for exponential functions eventually in this course. But one is, don't divide by 0, don't have negatives under even nth roots. Sine doesn't have any even nth roots, so there's no restrictions. Sine has no division, so there's no restrictions. So the domain should be all of R. When we graph this, we see that we get these key points. And this guy, so this should be 1 and then -1. And then what are we going to get? Sine of 0 is 0. And then we have these pi over 2 pi, 3 pi over 2, 2 pi. There's a bunch of unit circle values, but then we get sine of 1 is 1, or sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, sine of pi is 0. And then if we go to negative pi over 2, we're going to get -1. So we get a function that looks like, oh, I missed this. This is sine x on R. Definitely not 1-to-1. So we want to make it 1-to-1, but we notice that if we restrict it from here to here, it is 1-to-1. So to make it 1-to-1, we're going to restrict, and each function we're going to be 1-to-1 on slightly different domains or different intervals. So this is why they're not all the same for the trigonometric functions. What we're going to do is, therefore, do this. To make sine 1-to-1, we restrict the domain. this gives us the function sine from negative pi over 2 to pi over 2 into negative 1 to 1. It's the same sine function. You use the trigonometric unit circle values to find out what the values of sine are, just the way you would for the first one. But now the picture will be at negative pi over 2 and at pi over 2 and 1 and minus 1. We are now going to get a one-to-one function. And therefore we can invert this function when we give the definition of inverse function. I'm squeezing these in now because I'll go through on Tuesday the list of all the new transcendental functions and then their inverses. So 2 cosine, which goes from originally from r into negative 1, 1. So again, we have these key values. We have 1 and minus 1. So pi over 2, negative pi over 2. Sine of 0 is 1. Sine of pi over 2 is 0. Pi or negative 1, 3 pi over 2 is 0, and 2 pi is 1. So then we get cosine, which is just a shifted sine function. It's definitely not one-to-one. 1-1 is my lazy way of saying not, or one-to-one. So again, how are we going to restrict? It turns out it's a slightly different interval, but if you look at this from here to here now, we get a one-to-one function. So we're going to restrict it. So cosine from 0 to pi into negative 1 to 1 is a one-to-one function. This will look like what I just drew. We're close enough. This is cos as well, but now it's definitely one-to-one. So this is one-to-one. Notice that the intervals are different for sine x and cosine x, and of course they will be the same for tangent. For tangent function, which goes from its domain into all of the real numbers. What's the domain? A is equal to x in R such that x does not equal pi over 2 times k, k in Z. Not multiples of pi over 2, because cos of pi over 2 is 0, cos of 3 pi over 2 is 0. Yeah, reversible, injective. They have a lot of synonyms, yes, but we've got the microphone and we're the mathematicians, so one-to-one is what we call it, not practical. You can call it whatever you want as long as you understand the concept. You can call me hey you, it's or doctor, it doesn't really matter to me. I'll still know you're talking to me. One just sounds fancier. So what are we doing here? What do we mean by this? Tangent has vertical asymptotes, values where it's not allowed to. Tan is actually, how do we get this? Why? Because tan x is actually just sine x over cos x. And so now we run our two mantras. Do I have division? Yes. So this immediately says cos x cannot equal 0. And that says x should not equal multiples of pi over 2. So at pi over 2 or negative pi over 2, and then at 3 pi over 2, so we'll have a pi in there. And then what are we doing? We have these, and then in between these, we're going to have tangent. That's a horizontal line. So not one-to-one. But what can we do? We can restrict this to, so this is not one-to-one. I should use the same color, it doesn't matter. How do we restrict? We use tangent from open bracket pi over 2 to pi over 2 into the real numbers. And then what does that say? This function from negative pi over 2 to pi over 2 is a one-to-one function, and therefore can be invertible or be practically used. So this is one-to-one. We will do this with the other functions too. The ones we're going to get are cos hyperbolic, sine hyperbolic, and then tan hyperbolic. They basically look like the x squared and the x cubed, and then something slightly different. When we get to those, if we have to, we'll restrict the domain of those guys, and then we'll see what happens to them, and then we'll invert them. So this is what happens to, in particular, the x squared function or the trigonometric functions when they're not one-to-one. But when we want to use them practically, we still need to invert them. And so how do we do that? We first restrict their domain of definition to an interval where they are one-to-one. Then we invert those functions. And this is why your calculator can have sine minus 1, even though it's not a one-to-one function. They're restricting it onto that interval. So once we have one-to-one functions, what do we want? We want to now have the definition of what an inverse function is. This first definition algebraically will become extremely important when we use transcendental functions. It looks weird at first, but this is always the definition. This is the canceling process. And how do we reverse a process? How do we reverse adding 2 to something? You subtract 2 from both sides of an equation. You're used to this. How do I reverse multiplying by 2? I divide by 2 on both sides as long as it's not 0. 2 is not 0. And then now we're going to say, well, how do you reverse squaring? Well, as long as it's one-to-one and it's on an interval which is positive, then I can take the square root and that will cancel squared. How do I cancel x cubed or power functions? I take the nth root as long as I had a restriction. Now we're saying, how do I cancel sine? You have to use sine inverse. And as soon as sine inverse touches sine, you can cancel them off if you're in the domains that they've given you. We'll get into that a little bit once you've seen some of them. But Then now we're going to say, what is the inverse function for a function? And we're going to use a -1 symbol. Definition. Let f be this special practical function, which we call 1-to-1. So we're assuming a priori the function is 1-to-1. Other functions we can't invert. But if you've restricted this function a to where f is 1-to-1, unique points go to unique images, then what's the inverse? The inverse of f denoted by f-1. This doesn't mean an exponent, it means its inverse, unfortunately. And he's going to go from b to a. Notice that the domain of f is the range of b, and the range of f is the domain of b. They switch domains and ranges, these functions, because I have to go to the same place eventually as what I want. Is defined as this definition is extremely important. Everybody just nods their heads and tries to want to forget it. That will be okay with algebraic functions, but we're now going to do transcendental functions. And that weird definition is what I must cling to. F inverse of y equals x if and only if f of x equals y for any y in B. Or you can rearrange this. The book will write it like this. I've just flipped it around. So put this in here. I should do this. I don't know why it took so long to put the remark in here. But let's do that before we do an example. We can obtain the graph of a function. What this says is, remember, if we have, for every x value, we have xy, which is equal to x. We know what the y value is. It's f of x. And so when we invert that, the inverse graph has points yx, which is, what is x? Let me write it down here. X is inverse y, remember. That's where I got this from. You're like, where'd you get that from? If y equals f of x, then x is equal to f inverse y. So we get these points, i.e., what is this telling us? The graph of f inverse of x is obtained from the graph of f of x by reflecting about the line y equals x. what this will say is when we have a transcendental function, which is 1-to-1, but we have no way of algebraically solving for the inverse, and we'll never be able to write it down, we're going to have to call it a logarithm is the inverse of transcendental functions. This is why we had to get the name logarithm, because e to the x and a to the x, it turns out, is a 1-to-1 function, which is defined on all real numbers, but we have no way of algebraically inverting. So it must have an inverse. That inverse we're going to call a logarithm. The logarithm is the inverse function of the exponential function. This is what's happening eventually on Tuesday when we start doing exponential functions. So what do they mean by this? Pictorially, this says if I don't even know, so here's an exponential function. This is what it's going to look like, a to the x. Let's try it again. This guy, and this is going to be the point 0, 1. Why? Because if I'm looking at a to the x, a to the 0 is 1. So that says y of 0 equals a to the 0 equals 1. If and only if what was the definition. This says, or let's put f. That says f inverse of 1 will equal 0. F inverse, that says log base a of 1 is 0. Logarithm is the inverse. You don't have to know what this is yet. I'm just giving you this sneak peek when we do exponential functions and their inverses logarithms. This is how they're getting it. I don't even know what to call the logarithm yet. I just know whatever I called it, that's going to be the inverse of that exponential function, because a to the 0 is 1. I know that the inverse of 1 has to be 0. This is how I compute values in the inverse. And then what is the straight line? Here's the straight line, y equals x. And if you perpendicularly reflect across the line y equals x, you will get the graph of f inverse. And so this way I can make that be right about there. So we're reflecting across, and that tells me that this will give me the point 1, 0. They interchange points. And what that says is, if I want to know the value of an inverse function, I just found I compute in the original function and I get the inverse function values for free. And this is going to look weird when we do it for the trigonometric functions now, because the trigonometric functions are all invertible on different domains. And then they're going to say, what's arc sine of 1 over root 2? And you're like, I don't remember. And then you use the unit circle to find out sine of pi over 4 is 1 over root 2. Therefore, arc sine of 1 over root 2 is pi over 4. What? We have to use the definition of the inverse to find the values using the original function. And pictorially, this is extremely useful. You obtain, means that if I had a to the x here, I didn't even know that we're eventually going to call this log base a of x, who is just the inverse function of the exponential function. But I already know what log a looks like, because I know the graph can be obtained by simply reflecting the original function across the line y equals x. So even though I didn't know what to call it yet, I still know what logarithms look like, because whatever they are, every inverse function's graph is just obtained by reflecting it across the line, the original graph about the line y equals x. This is extremely useful. So let's do an example now, and then I'll let you have your morning back. Example. If f of x equals 3x plus 5, 1, show f is 1, 2, 1. 2, find f inverse of 8 before I find it, and then 3, find f inverse of x in general, or find an algebraic expression for the inverse. This is just a linear function. This is a straight line. Straight lines are hopefully 1-to-1, so they will be invertible. The inverse will be another straight line. How do we find this? Well, first of all, what we're going to do is how do I show something's 1-to-1? We'll do a bunch more of this on Tuesday. I'll overlap in all of our lectures as well, in case you miss one, or once we go back into class, I can't record the Tuesday lectures. And then you're like, well, I don't have, so I will try to overlap the material every time. And then even on the Tuesday ones, if I haven't recorded, I'll do a few questions about this when we do the recording lectures. So how do I show it's 1-to-1? You better start by assuming what? Assume we have x1 and x2 such that, so st is such that, what are we assuming? F of x1 equals f of x2. Well, yeah, unless you want to go, we can't go because of COVID. Once they restrict the COVID, they lift the restriction, then we'll go into in class. Until I make that announcement, 8:30 a.m. Yeah. You can come at 8 a.m. at any time you want, but I'll be opening the Zoom meeting at about 8:30 or 8:20. Yeah, you can show up early if you want. But yeah, if you want the whole hour, I can do the whole 8 hours, but eventually I have to take my daughter to school, so it just is unrealistic. I don't get to choose what time this is. Otherwise, I would have made it at like noon for us all, but the registrar's office does this. So now what's my first arrow? The first arrow is going to be the definition of f. What do I know about f? Well, it's 3x plus 5, the first two odd prime numbers. So that says 3 times x1 plus 5 has to equal 3 times x2 plus 5, because that's the definition of what f is. I'll send out an email every Monday morning, hopefully too, to remind you each week what you should be listening, what you should be watching or reading, and then when we're meeting. So I'll update you every week. Now, what do I do? This is where we want to start doing this, and this is what we're actually doing. What's the inverse of adding 5? Subtracting 5. So I'm going to find the inverse, I'm going to do the inverse of each algebraic operation. I'm going to subtract 5 from both sides. And what does that give me? Technically, that gives me -5 and -5, and then those cancel. And so that will give me how do I reverse multiplying by 3? The reverse of multiplication is division. So to unwind the operation of going forwards with a function which says multiply, I want to reverse by doing divide as long as it's not 0. So I am going to do what? I'm going to divide by 3. And what is that going to do? Technically, I'm going to multiply by 1/3 on both sides and then cancel. And that will leave me with sacre bleu, x1 equals x2. So if I assume that f of x1 equals f of x2, I just showed that x1 equals x2 for any arbitrary points. Therefore, f is 1-to-1. The 3 circles is therefore. That shows that f is 1-to-1. Now oh no, time's up right now. I can squeeze it in because I know some people now have other classes. 2, here's the key, f inverse of 8. I use the definition again above, if and only if what? So f is 3x plus 8. What value could I get it, or 3x plus 5? I already gave the hint. What value could I put in there to get 8? 1. So if I put a 1 in there, I get 8. If and only if by definition what? This is how I compute the inverse. Once I have the algebraic formula for the inverse, I can just do this explicitly. But do you see that I just found the value of the inverse function at 8 without ever knowing what the algebraic expression for the inverse is? I can get the values from the inverse function from the values of the function. If I know that f of 1 is 8, this has to mean that f inverse of 8 is 1. This is the definition of inverse. This will become much more important when we do transcendental functions where I cannot solve. This function is algebraic and linear, and we can just solve for the inverse. But I'm doing it anyways to show you that I don't need the inverse algebraic formula to find out values for the inverse. Because of this reflection business, I can compute using the definition. When I get a transcendental function, which I cannot invert algebraically, this becomes much more important, which we will do on Tuesday. We will do trigonometric functions, exponential functions, and their inverses logarithms. And then hopefully I will post these all on Blackboard. I'll put another file up there saying live lecture notes. So I will post these with the videos. So yes, I'll post these in Blackboard. Sometime, it won't be right now. I have to go prepare, and I have to do multivariable calculus at Concordia 215, and then I have to do linear algebra for the engineers back at McEwen from 2 to 3 today. I don't know what time, 12:30 to 2. I've got other classes today, so later today, after I'm done teaching all my classes, I will post these things, and then Thursdays, again, Thursdays I'll still be here, but you can watch all of these things. So Thursdays will be, you don't have to attend necessarily if you don't want to. It'll be me talking to a screen, whether you show up or not. And then yes, that's, I guess, the asynchronous where you can, I'll post these videos and you can watch them anytime you want. And I'll always post these PDFs as well. Anything else? I'll do part 3 next time because we didn't quite get there. And then other people have classes. But what do? You let y equal f of x. And then solve for x. I can do it y minus 5 equals 3x. And that implies that 1 over 3 y minus 5 is x. And then we interchange x and y. And that tells me that f inverse of x is equal to 1 over 3 x minus 5. And then if you try that, f inverse of 8 is equal to 1/3 8 minus 5, which is 1/3 times 3, which is 1. Oh, it did give us the same value. So if I have an algebraic expression for it, then I can compute. If I don't, I can use the definition to find out that f inverse of 8 was 1 before I even knew what the algebraic expression was. Have a good weekend. I'll regroup and I'll send you an email on Monday and I'll post all of this stuff and then we'll get through this semester. Also, I'll be in the McEwen Learning Center at some point when they send us out. I'm pretty sure Wednesdays and Fridays, but I'll double, and Saturdays. I don't sign on for Saturday again, but I'll let you know when I'm in the McEwen Learning Center as well. But for now, have a good weekend. I'll see you on Tuesday.